Hi, welcome back. In our previous lesson, we started with income and substitution effect. Today, we'll be moving on to the graphical representation of these two effects. But let's start with a recap. We saw that substitution effect is the effect of a price change on the quantity demanded due exclusively to the fact that its relative price has changed. So the consumer is simply substituting one good for another because of the change in the relative prices. And the income effect is the effect of a price change on quantity demanded due exclusively to the fact that the consumer's real income has changed. So, for instance, if the price of the good increase, the consumer's real income has fallen because their purchasing power has fallen. And this is what we meant by the income effect. So, to understand how these two effects work, it is useful to analyze them graphically. Let's start with a consumer named Ella who consumes good X and a composite of all other goods. So we will represent good X on the X axis and then all other goods on the Y axis. So if we start from Ella's original budget constraint, which is B1, and her utility maximizing bundle, which is E1, on indifference curve U1. So at this E1, Ella consumes X1 unit of good X and Y1 unit of good Y. So suppose the price of good X increases, which moves Ella to a new budget constraint B2 and a new equilibrium point E2 where she consumes X2 unit of good X and Y2 unit of all other goods. So what this example shows is that an increase in the price of good X led to a reduction in the quantity demanded of good X from X1 to X2. Our task here is to decompose the movement from X1 to X2 into income and substitution effect. Let's start with substitution effect. Recall that substitution effect is effect from relative price change alone. To isolate the pure substitution effect, we will be holding the income effect, which is the real income constant here. In this lesson, we will define L's real income as a level of utility. So essentially, when we say we are holding real income constant, we are simply referring to keeping Ella at her initial level of utility despite the change in price. In other words, what we are attempting to achieve is this. The price of good X has increased and Ella moves from one equilibrium to another, which means that she's moving from one indifference curve to a lower indifference curve. To isolate the substitution effect, we will have to give Ella enough income so that even though the price of good X has increased, she doesn't move from U1 to U2. So she's staying on the same indifference curve. Then the question here is, how much income is enough? So to find the amount of income that is required to move Ella back from U2 to U1 after the change in price, we will first have to make a parallel shift in budget constraint 2 until it touches the original indifference curve U1. So let's remember that this budget constraint 2 represents the new budget constraint after the change in price. It shows the new relative prices between good X and good Y. So to be able to keep Ella on the original indifference curve, acknowledging the change in price, we are going to draw an imaginary budget constraint that is parallel to B2. So this is represented as B3 here. So this imaginary budget constraint is going to be tangential to the original indifference curve. This brings us to a new equilibrium point EC. You can see that the imaginary budget constraint, which is B3, being tangential to the original indifference curve, brings us to this new equilibrium point EC. One thing to note here is that the vertical distance, which is C, between budget constraint B2 and budget constraint B3 is the amount of income required to keep Ella at her initial level of utility after the price change. The movement from bundle E1 to bundle EC. On the same indifference curve U1 is substitution effect, which shows how the quantity demanded changes from X1 to XE when the price of good X goes up, and simultaneously income is adjusted so that the level of utility is the same. So this shows a decrease in the demand for good X from X1 to XC. And this decrease is because the substitution effect is always negative. Always negative simply means that when the price of the good increases, substitution effect always says buy less of the good. And when the price of the good decreases, substitution effect says buy more of the good. If the movement from X1 to XC is substitution effect, then it means that the remaining movement from XC to X2 is therefore the income effect. Income effect shows how the quantity demand changes when income falls, but the relative price stays the same. We know that relative price stays the same because the budget constraint B3 and B2 are parallel. So two parallel budget constraint means the slope is the same. So the budget constraint B3 and B2 have the same slope, which means the relative price for these two budget constraints are the same. To summarize, when the price of good X increases, the quantity demand falls from X1 to X2, and this is called the total effect. Now, this total effect can be decomposed into two, which is substitution effect and income effect. Substitution effect is the movement from X1 to C. So when the price of the good increase, substitution effect says buy less of the good, which moved us from X1 to XC. Because the substitution effect is generated by changing the price and simultaneously compensating the individual with income, it is often referred to as the compensated response to a price change. The change in quantity that we actually observe, that is from X1 to X2, is called the uncompensated response. So in this example, the income effect of the price change lowers the quantity demand as well. So that moves us from XC to X2. So on our graph, the income effect is the movement from XC to X2. So what this means is that for Ella, good X is a normal good, and the income effect and substitution effect are both negative, so they reinforce each other. Both effects indicate that when the price goes up, quantity demand goes down, and vice versa. Hence, normal goods necessarily satisfy the law of demand, representing a negative relationship between the demand of the good and the price of the good. So this is all that we have on our lesson on the graphical representation of income and substitution effect, where we focus on normal goods. Our next lesson will be on income and substitution effect for inferior goods. If you enjoyed today's lesson, consider subscribing. Thank you.